Hey everybody, Dr. A here, and in this video we're going to be exploring an example of analyzing a shear stress and strain diagram. So let's go ahead and get started. I'm going to share my screen and I'm going to share a Word file that has an example of a shear stress strain diagram. So we're being told to refer to the diagram below, and we're being told that the material has a Poisson's ratio of 0.3. And we're being asked to compute the following. Part A is the shear modulus, and part B is the modulus of elasticity, okay? So let's take a look at what we have here. We have kind of a partial graph of a shear stress and strain diagram. Notice that on the vertical axis, we have shear stress tau, which has units of KSI, kips per square inch. And then on the horizontal axis, we have gamma, which is shear strain, and that has units of radians. And so looking at the graph here, we have this linear elastic portion, and then we get to this transition of this kind of nonlinear portion, or the start of a nonlinear portion where we have exceeded the proportional limit. And so it's pretty safe to assume that this value right here is 40 KSI. That's the proportional limit shear strain. And the 0.009 is the proportional, I'm sorry, the 40 KSI is the proportional limit shear stress. I was testing you there. And the 0.009 is the proportional limit shear strain. Okay, so let's go ahead and get started. The shear modulus, we're going to call this part A. We know that shear modulus is G, and we say G is equal to the shear stress proportional limit divided by the shear strain proportional limit, which there's gamma PL. And I'm going to, highlight these PLs and subscript them just to make my formatting look a little more professional. And we're going to say 40 KSI divided by 0.009 radians. And if we punch this in our calculators, we get 4,444 KSI as the shear modulus G. So that's a pretty straightforward calculation. Now, what about part B? Part B asks us to find the modulus of elasticity. Now, if you recall, we can relate shear modulus and Young's modulus, which is E, using Poisson's ratio. So Poisson ratio, shear modulus, and modulus elasticity are all related to each other. So the question is, how do we relate them? What's the relationship? So we can say E equals 2G times the quantity 1 plus Poisson ratio. And so we typically use the Greek letter nu for Poisson ratio. It looks kind of like a V right there. So we're going to say insert. And there it is. Okay. And, again, you could take this relationship and you could rearrange things. You could, depending on the problem you're being asked to solve, you could solve for G given E and nu, or you could solve for nu given E and G. So here we're being asked to solve for E when we know G and nu. So we're going to say 2 times 4,444 KSI multiplied by 1 plus the Poisson ratio. Poisson ratio is 0.3, so that'll be times 1.3. And we're going to punch this in our calculators. So let's see what we get. So we should get a modulus of elasticity of about 11,556 KSI. Okay, and that is our answer to part B. It is pretty much that straightforward and that quick. So if you found this video helpful, please hit like and subscribe. If you like all of this content, be on the lookout for other content similar to this. And thanks again for watching.